So here there is a stationary transmitter is operating on a wavelength of 3 centimeters. So transmitter is stationary and that is operating on a wavelength of 3 centimeters. A receiver is actually moving away from the transmitter, which measures a Doppler shift of 6 kilohertz. You're asked to find the speed of the receiver that is moving away from the transmitter. So it is just the opposite of the previous question. The scenario is exactly opposite. We have a transmitter and there is a receiver here. The transmitter is transmitting on a wavelength of 3 centimeters. The frequency shift that is observed in the receiver is 6 kilohertz. You are asked to find out the velocity of the receiver. Since the transmitter is stationary, the velocity of transmitter is 0, and therefore any relative velocity that you calculate will be purely because of the velocity of the receiver, which is what we have to find out. So again, the basic equation, we have seen another equation there, which is involving wavelength. So the relative velocity is equal to frequency shift into wavelength of transmitter. You can use this equation directly, or you can put it up in the normal equation, find the frequency of transmission, and then you can find the frequency shift, relative velocity. So frequency shift is 6 kilohertz into the wavelength is 3 centimeters. Now you have to make the unit same. 6 kilohertz is 6000 hertz into 3 centimeters is 3 10 to the power minus 2 meters. You're asked to find out the relative velocity in meters per second and also in knots. So the immediate answer will be in meters per second, which is
in meters per second it is 180 meters per second.
Meters per second, yes. In knots, it's going to be almost a double. So you can use your nav computer for that, 180 meters to knots. Or you can use a conversion, 1 nautical mile is equal to 1852 meters. And 1 hour is equal to
0.10 nautical mile per second. Multiply 0.
So I'm using basic conversion here. You can use the nav computer.
360 nautical miles per hour. Sorry, knots, I mean.
Yeah, nautical mile per hour, correct, 360. What is the frequency observed on the receiver?
10 gigahertz. Okay, yeah, frequency is 10 gigahertz minus 6 kilohertz.
Very good. It's 10 gigahertz, that is the frequency of transmission. Since the wavelength is 3 centimeters, by applying that equation C by lambda, you can find out the frequency as 10 gigahertz. And since it is moving away from the transmitter, it is minus frequency shift, which is 6 kilohertz. That is the observed frequency at the receiver. Alright, perfect. Yes, you can have the next question. An 8800 megahertz transmitter